In this video, we want to look at more examples on transformers. Now, in our previous video, we did look into detail about what transformers are, the type of transformers that we have, and all the necessary formulas that we need, all the necessary formula that we need to do calculations on transformers. Now, in this video, we want to look at some two questions that contains a lot and get to bring out our thinking ability. After that, we'll look at the past questions in the third part, and then everything together will be one full complete tutorial. So we have an example here. Let's look at it. The voltage from an alternator is 500 volts and it is fed into a step up transformer. Are you okay? Now this tends to be fed into an overhead cables with voltage of 20,000 voltage. A, we are to calculate the required turn ratio. B, we are to calculate the number of turns of the secondary coil if the primary coil has 26 turns. And then C, if the power of the generator is 100,000, okay, or 100 kilowatts, we have to calculate the current fed into the cables, right? Now this is fairly simple. Let's look at the solution to this problem. So we write down our solution. Okay, so let's write down the parameters that we have. So they say the voltage from an alternator is 500 volts and it is fed into a step up transformer. It means our primary voltage, which is EP, is equal to what? 500 volts, right? Now if this tends to be fed into an overhead cable of, okay, so which is then fed into a cable after the transformer has done its thing or has done stepping up the voltage. It is fed into an overhead cables and the voltage is 20,000. So it means our secondary voltage is 20,000. 1, 2, 3 volts. Okay, so A, we are to calculate the required turn ratio. Okay, now in our previous video when we look at transformers, we said that the ratio of the secondary voltage to the primary voltage is equal to the ratio of the primary current is to the secondary current, which is also equal to the number of turns in the secondary coil and then the number of turns in the primary coil. This is the expression that we have. So we can use any of this, either this or this, to calculate the required turn ratio, right? In this case, since we only have the voltage given to us and then we don't have this is the turn ratio, the ns over np, that's the turn ratio. Since we don't have this, or this is what we are supposed to find, and then we've been given this, we can equate this and then we can find our turn ratio. So our turn ratio, ns over np, will be equal to es over ep. So I'm just lifting it from here. So this guy over here is equal to this guy over here, right? That is what we have. So ns over np is what we call the turn ratio, and that is what we are finding. So in this case, ns over np is equal to our es, which is the secondary voltage over here, is 20,000 divided by our primary voltage, which is 500. So if we look at that, these two zeros will cancel this, and then 5 will go into 24 times. So with the 0 left over here, so it becomes 40. So we have 40 is to 1 over here. So therefore, okay, our turn ratio, or the number of turns in the primary and the secondary to the number of turns in the primary, is equal to 40 is to 1. Okay, so this becomes our answer. This becomes our turn ratio, right? 40 is to 1. Okay, so let's look at the B. So the B is saying we have to calculate the number of turns of the secondary coil if the primary coil has 26 turns. Okay, so let me find a space here to squeeze it in. So before that, let me get just some small space. So let me erase this. We've already said that this is the turn ratio. Okay, 40 is to 1. Are you okay? So if that is the case, let's look at B. B is saying that we have to calculate the number of turns in the secondary core, which we represent by NS. If the primary, so this one is unknown, if the primary turns is 26 turns, okay, if the primary turns is 26 turns, this is what we have over here. Now we've already established that the ratio of NS to NP is what? 40:1, okay, from the A aspect. So if that is the case, then we can say this implies that our NS we still don't know, so we maintain our NS, but our NP has been given to us as 26, so this will be equal to 40 divided by 1. So from here we cross multiply, this will multiply this, this will multiply this, so I have NS multiplied by 1 is equal to 26 multiplied by 40. Are we okay? So from there, 26 sorry, this is supposed to be 25 tenths, okay, it's supposed to be 25 tenths, so we are dealing with 25 tenths, 25 over here, so this is also 25, so let me use another color for that. Okay, but regardless whether it's 25 or 26, the answer you will get is just simply multiplication. So this side is going to be 25, okay, multiplied by 40, and then if we do that, it's going to give us 1,000 turns. Okay, so it means that the number of turns in the secondary side is 1,000 turns. Are you okay? So this is the answer for the B part. All right, so now that we've calculated the turn ratio, and then we've also looked at the number of turns in the primary, which is 25, and that of the secondary, which is 1,000, which tells us since the number of turns in the primary is lesser than the number of turns in the secondary, it tells us that it is indeed a step up transformer. If you've watched the first part of the tutorial, you will understand what we mean by this. All right, so from here, let's look at the C part, which says that if the power of the generator is 100 kilowatt, we have to calculate the current fed into the cables. Right now, remember the current fed into the cables, okay, the overhead cables, the current fed into that cable becomes the current output, right, or I secondary, or IS, that is that. So let me get some space, and then we quickly look at the solution to that particular side. Okay, so let's look at that. So we've been asked that if the power of the generator, so the power of the generator, okay, is 100 kilowatts, okay, we have to calculate the current fed into the cables. Right now, if you look at this, the current fed into the cables is the IS, or the secondary current. Okay, the current from the power into the transformer is the IS. So we have the primary current, are you okay, and then we have the secondary current, okay, which the question is demanding that we find. So first of all, we need to determine the primary current from the power given to us. Now remember, we've established the fact that the secondary voltage is 20,000 from the question, and then the primary voltage, okay, or EMF is given to us from the alternator, which is 500 volts. We already have this. So if that is the case, power, okay, so I'll make it P subscript P. That means the power fed into the primary core, okay, is equal to the voltage, which is the EP, multiplied by the current IP. Are we okay? So therefore, from here, to find the initial current, or the current fed into the primary core, it means that IP is equal to the power, okay, divided by the EMF, right? It means we divide both sides by EP here, EP here. So this will cancel this. Our IP becomes PP over EP. Right now, these are just initials, right? So our answer over here is that our power, which is 100,000, K is times 10 to the power 3, so 3 more zeros, over the initial potential difference EP is 500. So I bring my 500 over here. So therefore it implies that my primary current is equal to 100,000 divided by 500, and this will give me 200 amperes as my answer. Now that I have my current, there are so many ways I can go about this to find the answer. I can either use E secondary, EMF in the secondary coil over EMF in the primary coil is equal to current in the primary coil over current in the secondary coil to find that, or I can also use the current in primary over the current in secondary is equal to the number of turns NS over NP. I can also use this. Now mind you, NS over NP, we've already found a ratio for it, that is 40:1, so we can use that as well. So any of this will actually give you the final answer, so long as you quote the formula really well. So I will be going with okay, I'll be going with this, right? But we can also use this. So in fact, let's use both and see if we'll get the answer, right? So using this first, our IP, which is 200, so I have here 200 over IS, which I'm supposed to find, is equal to NS over NP, right? The NS over NP, the ratio is 40 is to what? 1. We've already established that. So therefore, this means that the 200 will multiply the 1 over here. So we have 200 is equal to 40 IS. So to find IS, we divide both sides by 40 by 40. So our IS will be equal to, this will cancel this, this will also cancel this. So 20 divided by 4, that will give us 5. So we have 5 amperes as our answer. Or we can also use this side. So let me use a different color to show that one. So our ES is 20,000, okay, which is this guy, over our E primary, which is 500. And that is equal to our IP, which we found is 200 over our IS. Okay, so if we cross multiply, we realize that we will have 20,000 IS is equal to 500 multiplied by 200, right? So we can divide both sides by 20,000. This will cancel this, right? So here we just cancel a bunch of zeros. This 1 0 will cancel this, the second one will cancel this one, the third one will cancel this one will cancel this guy. Are you okay? And even the 2 will cancel the 2 over here, so we are left with 5. So therefore our answer over here, IS, is 5 amperes, right? So regardless of whether we use this expression or this expression, we are still getting 5 amperes as our answer. Very good. All right, so let's have a look at another problem, and then we end the second part of this tutorial. So we have a transformer has a primary coil of 500 turns and a secondary coil of 25 turns. This one is pretty straightforward. So we've been asked A, what sort of transformer is it? B, we have to calculate the turn ratio. Very easy. C, if the primary coil is connected to a 240 volt mains, we have to find the voltage in the secondary coil. Also very easy. We also to calculate the efficiency of the transformer if the primary current is 0.6 amperes and the secondary current is 8 amperes. Very easy, straightforward. Let's dive in. So we write down our solution. So the transformer has a primary coil of 500 turns. So our number of turns in the primary is 500 turns. Okay, and then the secondary coil has 25 turns. So our NS is 25 turns. Okay, now they are asking us A, what sort of transformer is this? Now, if the primary coil has more turns than the secondary, this is a step down transformer because it is moving from 500 to 25. So it's a step down transformer, right? But if it is moving from let's say a lower number in the primary to a higher number in the secondary, it is a step up. So this is a step down transformer. That is the A. Now the B is saying we should calculate the 10 ratio, right? Now the 10 ratio is either NP over NS or NS over NP, regardless of how you want to do it. So it's either this over this over NP. So let me do it over here. So B is either NS over NP, okay, depending on how you want to do it. So I'll use this. So NS is 500. Sorry, NS is 25. So let me clear that. So let me clear this. So our NS is 25. Our NP is 500. Okay, so this will cancel itself one. It will go into 52 times. So with this 0 come down by is 20. So the ratio is 1 over 20, right? So therefore, it means that our NS is to NP is equal to 1:20. So the ratio is what? 1:20. It can also be 20:1 if you bring the NP first is to NS, then it will become 20:1, right? Regardless of how you position it, it is still going to be correct. Now let's look at the C part. The C is saying if the primary coil is connected to, so the voltage passing through the primary coil is 240 volts. Okay, we have to find the voltage in the secondary. We have to find the ES. That is what we do not know, right? Already we have the ratio of NS to NP, so we can just use that in conjunction with this, and then we will get our answer. So for this ES, okay, the secondary voltage over the primary voltage is equal to the number of turns in the secondary over the number of turns in the primary. This is the ratio we'll be using. Are you okay? So from here, to make the secondary voltage, the subject ES will be equal to this will multiply this, this will multiply this. So we'll have EP multiplied by NS, okay, this and this. So we'll divide it by NP. So divided by NP. So that is it. So this will be equal to our EP is 240 volts multiplied by the number of turns in the secondary, which in terms of ratio, the NS is 1. So we'll use 1 over here over the number of turn in the primary is NP over here, which is the 20 at the bottom here. So we have 20 over here. So this is basically 240 divided by 20, and then that will give us if you compute that, that will give us 12. So our answer is 12 volts, right? It is 12 volts. Now because it is a step down transformer, we can see that the voltage that is applied to the transformer is 240, but it has reduced it to 12 volts. Are you okay? And this also proves that our answer for A, which is a step down transformer, is correct, because a step down transformer steps down the voltage or reduces the voltage output compared to the input. All right, so now that we have this, let's go ahead and look at the D option of this particular question. Now the D is saying that we should calculate the efficiency of the transformer if the primary current is 0.6 and the secondary current is 8 amperes, right? So let's have a look at that. Okay, so D, we have to calculate the efficiency, right, of the transformer. So we're told that the primary IP current is 0.6 amperes, and then the secondary current IS is what? 8 amperes. Now the efficiency of a transformer, efficiency, let me make it like this, is equal to power output, okay, over power input multiplied by 100, that is it. Now for power output or input, power output, which is let me make it power output, P subscript O, it means the power in the secondary coil. Okay, so that would be the voltage in the secondary coil multiplied by the current in the secondary coil. Now the power input, which I'll make Pi, is equal to the power in the primary coil. So that would be potential difference, or EMF in the voltage in the primary coil multiplied by the current in the primary coil. So this is effectively equal to ES IS over EP IP multiplied by 100, which is equal to the ES is what we found is 12 multiplied by the IS as 8 over here. Then we divide that by, remember we are multiplying all by 100. Then we divide that by our E primary is 240 multiplied by our current in the primary is 0.6 over here, right? So 12 multiplied by 8 will give us 96, and then 240 multiplied by 0.6 will give us 144. Okay, then all of this multiplied by 100, and this will give us a percentage of 66.67%, right? So it means that the efficiency of the transformer is this, right? But if you were asked to convert it to the nearest whole number, then this becomes 67% efficiency, 67% efficiency for the machine. So thank you so much for watching. This is how we solve some further questions on transformers. So in the next video, we'll be looking at some past questions, objectives on these transformers, and then we will look at some other past questions which are subjective as well, to understand to further enhance our understanding of transformers, and then we put all the videos together to make one full tutorial. Okay, so thank you so much for watching, and if you're new to the channel and you find this type of tutorials very helpful, like, comment, and then share the video, and also don't forget to subscribe. Peace.